Assalamualaikum. I am Mohammad Tawil Haq, a third semester undergrad student majoring in computer science from UTS Dhaka. So today I'll be explaining about encoder, what is it, how it works, and how to implement it on Tinkercad. So let's get started. So what is an encoder? So an encoder is basically a combination of circuit that translate the human language into the language that can understand the computers. So we all know that computers cannot understand our language, so we have to translate it for them so that they can understand. So these work. So encoders do this work. They translate our language into computer readable language. There is actually the reverse operation of decoder, because decoder exactly do the opposite thing. So decoder do the translate the computer language to human readable language. So encoder do the exactly do the reverse thing. So here we can see a block diagram of encoder. So here if we give 2 power n input lines, we will get n output lines. So here we can see that we gave 4 inputs, for that we're getting 2 outputs. Like this, if we give 8 inputs here, so for that we will get 3 outputs here. And if we give 16 inputs here, we will get, for that we will get 4 outputs here. So the general relation is, if we give the 2 power n input lines, we will get n output lines. So now we will talk about 4 to 2 encoder. By seeing the name, we can understand that 4 to 2, that means there will be 4 inputs, and for that we will get 2 outputs. Here the inputs, we denoted them as y0, y1, y2, y3, and the output we denoted as a0 and a1. For 4 inputs, we are getting 2 outputs. I denoted them as a0 and a1. You can set them on your own, whatever you like. So this is the block diagram. Now we see the truth table of this, that how it works. So there are 4 inputs and 2 outputs. So there treat the inputs as 4 switches. Like this is a switch, y0 switch, y1 switch, y2 and y3. Treat them as switches. Suppose there are 4 switches. So at first there are 4 inputs, so 0 to 3. This is 0, 1, 2 and 3. So if you press the 0, if you press the switch 0, for 0, the output that we'll get is the value of this, the binary value of the 0. So what is the binary value of 0? The binary value of 0 is 0 and 0. So we're getting 0, 0. And we press first we press 0, then we press 1. We pressed 1, y2, 1. So for that we will get the binary value of 1. So what is the binary value of 1? Which is 0, 1. So we got 0, 1 as output. Then we pressed 1, then we will press 2 as input. So when we press 2, we got the binary value of 2, which is 1 and 0 as output. And then we will press 3, we press 3 and we got the binary value of 3, which is 1 and 1. So you might think that why we are just pressing a switch at a time, why we are not pressing the other switches. So there is a rules like this in encoder, that you cannot press all the switches or more than one switch at a time. You can just press one switch at a time. So we and at first we just pressed switch 0. So for this this is 1, and the other switches y2, y1 and y0 are 0. They will not work. And the same for other 3, we pressed 1, we got the binary value of 1, 0, 1, and here we can see y0, y1 and y3 are turned off, 0. They will not work. Only one switch is working. So only one switch will work. We can press only one switch, and we cannot switch all the switch or more than one switch at a time. So that how we got the outputs of 4 to 2 encoder. Now we will see the logical expression and the circuit diagram for 4 to 2 encoder. for logical expression you can see that our output was a0 and a1. For a0 we got y1 plus y3, and for a1 we got y2 plus y3. So how we got this? To understand this we have to go back to the truth table. So here is the truth table. For a0, this is the row 0, this is the row 1, 2 and 3. So we'll have to take the value where take the value of a0 where there is 1. So for a0 we're seeing that in the line 1 0 1 there is a 1, so we'll take 1 y1, and there is line 0 1 2 3, and in line 3 there is a 1. So in line 1 and line 3 there are two ones, so we'll take y1 and y3. So that's why the logical expression is like this: y1 plus y3. And the output 1, there is two ones in line 2 and 3, so we will take y2 and y3 as logical expression, y2 plus y3. So while seeing this you might think that when we take the when it wrote the logical expressions, for 1 the expression should have been like this: for 0 y3 complement, for y2 y2, and for y1 y1 complement, and for y0 y0 complement. The full expression should have been like this: y3 complement, y2 yn complement, and y0 complement. But we took only y2. Why we did this? So see there, the value of y3 is 0, the value of y1 and y0 also 0, so the value of them is 0. So that's why basically they will not work. So that's why we did not took them, we took only y2. And for this one the logical expression should have been y3 complement, y2 complement, and y1 complement, and y0. But we took only y0 because y1, the value of y1 y2 and y3, they all are 0, so they will not work. That's why we only took y0. So the logical expression is will be like this. For that for a0 output we got the expression y1 plus y3, and for output a1 we got the y2 and y3 y2 plus y3 as logical expression. Now we will design a logical circuit for these expressions. So firstly you saw you've seen that there are three inputs: y1 y2 and y1 y2 and y3. So we'll connect them through an OR gate because there is a add operation. So for a1 we will have to connect y2 and y3. Here you can see y2 and y3, you connected them through an OR operation. For that we got a1 as output, and for a0 output we connected y1 and y3, y1 and y3 connected through an OR operation, OR gate. So that's how we got a0 as output. So this is the logical expression and logical circuit for 422 encoder. Now we will see the 823 encoder. 823 encoder, or you can say this also octal to binary encoder, as we all know that octal has 8 bits. So you can say this octal to binary encoder instead of 823 line, as you wish, whatever you say. So by seeing the name it is already predictable that there will be 8 inputs and S3 line, so there will be 3 outputs. For 8 inputs there will be 3 outputs. So we generated the inputs as 0 to 7, y0 to y7, 8 inputs, and the output are a0 to a2, 3 outputs. So now we will see the truth table for this. Here you can see 8 inputs and 3 outputs. So we already said that you had to treat them as switch. So firstly we placed the switch 0. For 0 the binary value of 0 is 0 0 0. Here we are getting outputs, 3 outputs, that's why we wrote them in 3 bits, so 0 0 0. And then we pressed switch 1, the binary value of 1 is 1, so 0 0 1. Then we pressed y2 2, button 2, the binary value of 2 is 1 0, that's why we got 1 0. Then we pressed 3, switch 3, the binary value of 3 is 1 1, so we wrote 0 1 1. Then we pressed 4, for that we got 1 0 0. Then we pressed 5, that's why we got 1 0 1. Then pressed 6, we got 1 1 0. And finally we pressed the switch 7, for that the binary value of 7 is 1 1 1, so we got 1 1 1. This is the truth table, so this is how it worked. Now we'll see the logical expression and the circuit diagram for this 8:3 line encoder. So for the logical expression part, for A0 output we are getting y1 plus y3 plus y5 plus y7. So for A0, see there is 1 here and here, here and here. So in which row? This is the row 1, row 3, row 5 and row 7. This is how we can remember. So this is row 1, that's why we're taking y1, and this is row 3, so y1 plus y3. Then row 5, y1 plus y3 plus y5. Then row 7, so plus y7. That's why a logical expression for A0 is y1 plus y3 plus y5 plus y7. So you could have thought that you could write the expression like this. For 1, the expression should have been y0 complement, y1, y2 complement, y3 complement, y4 complement, and for 0 complement for 1 just the switch. But as there is only 1 and the others are 0, so they will not work, so you took only the 1, the switch that has 1. That's why we just shorten it, and the logical expression of this for A0, y1 plus y3 y5 y7, and for A1 we got y2 y3 plus y6 plus y7, and for A2 we got y4 plus y5 y6 and y7. So then we connected them through an OR gate. Here you can see it's very simple. And for A0 we got we had to connect y1 y3 y5 and 7. Here we can see y1 y3 y5 and y7. We connected them through a OR gate. So the rest of the two have been done by same. Now we will see how to implement this on Tinkercad. So let's go to Tinkercad. So here is the Tinkercad. Let's get a new one. I have done it before. So here in Tinkercad you have to create a new circuit. To implement this, the basic component is you need a breadboard. Just search a breadboard. Try to take a bigger one. So this is the biggest one out here. So we took this, and for the power supply you just search power. So here we got this for power supply, and we are implementing this for 8:3 encoder. So 8:3 means there will be 8 inputs, means 8 switches. So we need switch. So just search switch. So here switch. But you can see that in this switch there are only 4 inputs. Count them like 0 1 2 3, and we need 4 more. So just take another one. So count 0 1 2 3 4 5 6 7. 0 to 7 means 8. So we got our 8 inputs. Now connect them to the power. This is positive, connect it to the positive sign, and this is negative, and connect it to the negative sign, and connect them also. This is plus, and this is plus, and this is minus, and connect it to minus. And we have to connect the switches too. Switch one by one. Next, So we've done connecting, we've connected all the switches. So now as you can see in our logical expression for 8 to 3 encoder, there is a we need an OR operation to implement this, so we will need OR gates to implement this. So the IC number of OR is 7432. Let's search 7432. Say here is the quad OR gate, means this is two, so this is on thing to note that this is 2 input OR gate, but in the slide we saw that the 4 inputs are connected in a same OR gate, but we cannot do this here in Tinkercad as it is 2 input OR gate. So let's at first connect them to the connections. This is the minus, and this is we connect the ground, and this is the power, and we connect it successfully. And so first, this is the switch, this is the inputs. We'll have to give the inputs here, and we'll get the output, which is will connect a LED that will turn on. If they turn on, we'll get to know that our test is successful or not. So firstly, we'll do for A0. For A0 we got Y1, Y3, Y5 and Y7, means 1, 3, 5 and 7. So let's remember this 1, 3, 5 and 7. So this is 0. This is written 1, but remember we have to do as 0 to 7. So this is 0. So we have to do 1. So this is 1. Connect it here. 1, 3, 5, 7. Connected 1. Now connect 3. 1, 2, 3. This is 3. As this is 2 input gate, so we'll have to get the output here. This is as output 1. So this is output will work as input in the next operation. So 1, 3 successfully done, and 5, 4 and 5. This 5 will work, connect here, and we're getting the output. This output will work as input in the next operation. We have done 1, 3 and 5, and the rest one is, the last one is 7. So this is 7, and we will connect this 7 here, and the output is here. So to check this, we need LED. So this is LED. You can change the color. This is the red color. You can change if you want. This is the -1, and this is the output line. We're connecting this here. To check this, so how will check this? How will make sure if this works fine or not? So when you press, as we already said that you can only press one switch at a time. So when you will press 1, the light will turn on, and it you have to turn it off, and then if you press Y3, the switch 3, it will also work. But if you press the switches outside them, like you press Y2, it will not work, or if you press Y4, it will not work, or if you press Y6, it will not work. And for 0, no switches will work. So the light will turn on only for Y1, Y3, Y5 and Y7. So let's try it, like start simulation. If we press 0, it will not work, it's not working. But if you press 1, so here is, let's set the voltage to 2. So we pressed 1, so the bulb turned on. So for 1 we know the 1, for 2 it is not working, but for 3 it will work. So this switch 3, it works fine, and for 5 it will work, and for 6 and 7, for 7 it will work. So we have successfully done it. And there, for this is the A0 output, this works fine, and the remaining two are A1 and A2. For A1 we will have to connect 2, 3, 6, 7. Let's remember this 2, 3, 4 and 7. So we will need another OR gate. Just search over here. So the IC number is 7432. Here is another OR gate, and let's connect it here. ground to the minus, and the power to the plus. So the logic expression was 2367. So 2 0 1 2, here is 2 2 3, this is 3, and next line is output. This will work as input for the next line. We have done 2 3, next is 6 4 5 6, this is 6. So 6, the work in here. The last one is 7, there is 7 here. Then this is the output. So for this, to check this, we will need another LED. So let's change the color to green. Let's change the color to green. So the output line, we connecting this to the LED, and the power line to minus. So now check. The LED will turn on, LED 2 3 6 7. Here you can see there is also 3, there is also 7. So if when we press 7, the both light will turn on, and when we press 3, the both line will turn on. But for 2 and 6, this is only one. So 2, so let's start simulation, and if we press 2, this is working, and we press 3, this bulb is turning on. We press 7, this is 7, these both bulbs are turning on. So this also works fine. Now the last output, which is A2. For A2, we have to connect 4 5 6 7. So let's get another OR gate, which is 7 4 3 2, and let's connect it. So 4 5 6 7. So 0 1 2 3. This is 4. Here is 4. Here is 5. The output will go as input, and now this is 6. This is 6 will go as input, and the output will go as input here, and this is the 7 will connect here. And to check this, we will need another LED. So get it here. We can change this color to yellow. So let's connect this. And here. So we're done. So for if you press 4 5 6 and 7, the yellow will turn on. At the same time, you can see that when we will press 7, the A2 will the bulb for A2 will work, the A1 output will also work, and for the output A0, this will also work for the Y7. So if you press Y7, 3 bulbs will be turned on. So let's check. Let's start simulation. We're pressing the 7, 3 bulbs are turning on at the same time. Press 5. If you press 5, 2 bulbs are turning on, green one and the yellow one. And if you press 4, only one is working, because for 4, let's see, there is only on 4. In A1 or A0 there is no 4, so that's why just only yellow bulb is working. So we're done with implementing. It's easy. Let's try it on your own. This is, we're done with our implementing. So there are some uses of encoder too. So what are them? We just say that they translate the human language into computer, into the language that understand compare. So this is the main thing basically. But it is also this it is also perform as a binary operations such as addition, subtraction, or multiplication. Like while while doing addition, subtraction, multiplication, we give two decimal inputs. Like we are adding two numbers like 2 and 3, but computers will not understand a decimal number. So what will it do? It will convert to the decimal number into binary so that it can understand, and the 3 it will also convert the number into binary so that the computer understand. So encoder do this thing so that they can understand our language, the human language. That's basically encoders too. So, and I have given the Tinkercad link in my description box. You can access that from there if you need. And if you have any questions regarding anything in the video, you can ask that in the comment box. And that's it all for today. Thank you for watching.